In this screencast, we will discuss the limbic system as well as learning and memory. We will start our discussion of the limbic system by describing the limbic system and then moving on to describe the functions of its components, including the hippocampus, the amygdala, and the hypothalamus. The components of the limbic system are illustrated and highlighted in this image shown here. Limbic comes from the word limbus, which means border, and this reflects the fact that it is composed of nuclei and tracts that run along the border of the cerebrum and the diencephalon. This includes structures that encircle the upper portion of the brainstem, the corpus callosum, as well as the diencephalon. I want to be clear that the limbic system is not an anatomical grouping of structures, but rather a functional grouping of structures. The components of the limbic system are located in various parts of the brain, and they're connected to one another by fiber tracts, which allow for communication and integration. The limbic system is often referred to as the emotional, visceral brain. I like to think of the limbic system as where emotion intersects physiological function. Most structures of the limbic system contain what are called gratification centers and aversion centers. Gratification centers are those that stimulate feelings of pleasure or reward, such as the fullness that you feel after you eat a meal, or you feel quenched after you have consumed a beverage. Aversion centers are those that produce feelings of sorrow or fear or loss. The limbic system plays a role in several memory and emotions, such as pleasure, thirst, hunger, fear, anger, affection, and sex drive, just to name a few. The first component of the limbic system I'd like to discuss is the amygdala. The amygdala links emotions to memory and is critical to allowing one to respond to perceived threats, such as angry or fearful facial expressions. Damage to the amygdala causes a person not to be able to recognize fearful expressions in others, or to fail to become fearful when you are in situations where you should be fearful. The amygdala also appears to play a role in linking memories and olfaction or smell. The second component of the limbic system is the hippocampus. The hippocampus functions in the retrieval of long-term memories. Damage to the hippocampus produces a condition called anterograde amnesia. This is the inability to form new memories. Memories that existed before the damage to the hippocampus are still available. However, new memories cannot be created. The third and final component of the limbic system that we're going to discuss is the hypothalamus, and we talked about its role in the limbic system earlier. Most output from the limbic system, that is, the outward expressions and emotional behavior, is relayed through the hypothalamus. So anger, pleasure, feel, contentment, aggression, sex drive, and the actual behavior that exemplifies these emotions appears to be the result of the activity of the hypothalamus. If you recall, the hypothalamus is also a major center for the control of visceral organs. So the fact that it is involved in emotions as well as visceral functions makes it easy to understand how stress, for example, can cause changes in blood pressure, stomach upset, as well as heartburn. Our next topic will cover learning and memory. Your learning objectives are as follows. Define learning and memory. Contrast immediate, short-term, and long-term memory. Define memory consolidation. And finally, describe memory consolidation, including the role of the hippocampus and the factors that influence the process. Let's start with some definitions. Learning is the ability to acquire new information or skills through instruction or experience. You can learn new information by simply being exposed to that information through a video like the one you're watching now, or reading a book, or someone presenting live in your presence. You can simply learn new information or facts, or you can learn to do something that you previously were not able to do, like a new dance move, or to ride a bike, or to assemble a puzzle, for example. Memory is the process by which new information is acquired through learning. That information is stored and then can be retrieved at a later date. I think of memory as like a book that you receive, and then you take that book and you put it on the shelf. And then later, when you need that book, you go to the shelf and you retrieve it. Memory works in a similar manner. As you learn new facts or how to do things that you previously did not know, there are structural and therefore functional changes that take place in the brain. And that brings up this concept of neuroplasticity, or the ability of the brain to change or be molded, shall we say, to make the retrieval of memories more efficient. As you learn, neurons change their interactions. Their synapses are modified. This could result in an increase in the amount of neurotransmitter that is released. It could result in a change in the number of receptors at that synapse, or maybe even possibly a change in the combination of neurotransmitters that might be released at a synapse. Learning and memory are associated with persistent changes in the brain and how neurons in the brain communicate. Learning and memory include changes in the association areas of the cerebrum as well as portions of the limbic system, especially the amygdala and the hippocampus. In this model that I am going to share with you, I am going to include immediate memory, short-term memory, and long-term memory in our discussion. This will vary slightly from the model that's presented in your book, which only includes short-term memory and long-term memory. But you'll see that the differences in the model I'm going to present and the model that's presented in your book, the differences are really negligible. Let's define immediate memory as the ability to recall information from an ongoing experience, such as you're reading a phone number while you're dialing the number. You're literally having to retain that information for less than a second. Short-term memory is the ability to recall information for a few seconds or maybe a minute after you were exposed to that information. For example, if you were to read a phone number, then cross the room, and then dial that number. Short-term memory is eventually lost. It's not something that you retain for more than a few minutes. Frequent retrieval of stored information converts short-term memories to long-term memories, and this process is called memory consolidation. You ever looked up a phone number or looked up a piece of information so many times that you eventually remembered it? Or perhaps there was a song that came on the radio so many times that eventually you knew the words to the song, even if you really didn't even like the song. This is due to memory consolidation, where short-term memories were eventually converted to long-term memories. And with long-term memories, you have the ability to retrieve that information days, months, even possibly years after you acquired that information. The hippocampus appears to play a major, if not crucial, role in memory consolidation, because what we find is damage to the hippocampus prevents the creation of new memories, a condition known as anterograde amnesia. It does not cause the loss of previous memories, but it causes the inability of the brain to form new memories. For example, someone with anterograde amnesia, you could meet them, you could tell them your name, you could hold a conversation with them, then you could maybe leave, possibly to go to the bathroom, come back to resume your conversation and find that the individual doesn't know who you are and has no memory of the conversation that you just had. Let's talk about factors that can influence memory consolidation. And this is very important to learning. And I hope that you'll be able to apply these factors to your study skills and study habits, and that you will hopefully understand some of the study tips and study skills that I have tried to share with you. So emotional state can affect memory consolidation. When you are more alert, it is easier to transfer information from short-term memory to long-term memory. Things that shock you or make you very happy or maybe very sad tend to increase memory consolidation. Rehearsal. You probably have heard the expression practice makes perfect. I have certainly talked in class about how if you do something over and over and over again, eventually the information moves from short-term memory to long-term memory. That does appear to be the case. Repetition appears to transfer information from short-term memory to long-term memory. Association of new information with old information also appears to promote memory consolidation. This is why I often use analogies, and I'll tell you to apply what you know to what you don't know, because that appears to enhance memory consolidation. And I just want to mention that there are some involuntary memory consolidation that occurs where perhaps I am lecturing on a topic and without, attempting to, you recognize, a shirt that I'm wearing or a pair of pants that I am wearing, right? This is sort of involuntary information that is consolidated. This image from your book illustrates the process of memory consolidation. So you first have to have stimuli that's detected by both your general senses as well as your special senses. And those afferent inputs, or that sensory information, goes into temporary storage in the cerebral cortex. Perhaps you're using that information for just a few seconds, maybe while you're dialing a phone number, for example. But after that, you forget the phone number or the address you looked up or whatever, and that information is lost. But perhaps you needed to retain that information for several seconds or minutes, and it was moved into short-term memory. But then after you finished whatever activity you were engaged in, you forgot that information. And again, that data is lost. However, in some cases, that short-term memory is transferred to long-term memory, where perhaps you remember the information for days or months or years. The factors that influence that data transfer include the emotional state that you had at the time, if you were very excited, or if you were shocked or horrified or found the information really interesting. That would help consolidate the short-term into long-term memories. If you had been exposed to that information previously, the rehearsal or repetition helps move the short-term memories to long-term memories. That's one of the reasons why I advocate that you read the book before attending the lecture. Then you attend the lecture, and then afterwards you look over your slides. You read through your slides, and you explain the slides to yourself. By that time, you have exposed yourself to the information 3 times, right? And that is the rehearsal activity that will help move those short-term memories to long-term memories. And lastly, associating new information to old information through analogies also helps transfer those short-term memories to long-term memories.